All right, so if I'm just gonna go over the first problem, I think.
Excuse me, teacher. Today we are going to do the book work 6.3 and 6.5.
6.3 and 6.4.
Okay.
So we are really leading up to something. All we're doing is factoring. We're rewriting these things in a different way. We're not solving anything yet until tomorrow, right? That's basically where this is leading. Like how do we actually solve these things? And so if I see something like 25v squared, like enable share screen. Okay.
Looks like Brian's asking if you can enable the whiteboard when you're in the groups. I think you did that, didn't you?
I can enable the share screen if y'all remind me, because it doesn't come up automatically.
Oh,
But
okay.
I did it, so you should be able to share screens when you're in groups. Just to remind me if you want to do that, and I can set that setting. But I think they give you the option to share a whiteboard as a student, but I could be wrong. If I'm looking at this thing, does this look like, well, there's basically two things that we learned, right? There was like the difference of squares, and then there was the, what do they call the other thing? Perfect trinomial, is that what it's called? I don't remember what it's called. But it's not one of those. It's two things. So I want you to notice basically two things about this, right? It's two terms, and in the middle, it's got to be subtraction. So if we have two terms, if it's anything that's not subtraction, guess what you can tell me?
Prime.
It's prime, right? We can't factor anything unless there's like some subtraction either in the middle, or I guess they could have made one of it like maybe negative, positive, right? They could have done something maybe tricky like that, but the signs have to be opposite. So there is some subtraction in the middle, so we should be able to factor this thing. So I want to look at this thing. So if I look at 25v squared, is that a perfect square? Is the first thing you should ask yourself.
Yes, 5 times 5.
Yeah, so 25 is perfect. I can do it with, come on, Pin. If I take the square root, it's 5. What about that v squared?
Yeah, it's good too.
I can take the square root of that, and it's going to be what?
5b.
Just v, right? That's
And
it.
v. It's not
So we got a 5v is the first term. The other thing I see here is 1. Is 1 a perfect square? That's one of the silly ones, probably.
Do you need to add
Yes.
parentheses on this?
1 is a perfect square. What is the square root of 1?
1.
It's just 1.
1.
And so in order to get this sort of pattern happening, have a 5v and a 1, I have a 5v and a 1, and what about these signs?
One needs to be a positive and the other one needs to be a negative.
Yes, that's the only way we're going to get that middle v term to cancel out. So if we go back and do distribution to check this thing, you're going to notice like plus 5v minus 5v in the middle. That is horrible. I think it's 25v squared here and then a minus 1. Basically, what's going to end up happening is this middle term ends up canceling. That's why we only have 2 terms.
Could you please also include what the difference is between something like this, where they see 2 terms? Because when they had that on their work yesterday, and I told them, because it was 2 terms and there was no C, that they factor out the GCF. Can you tell them the difference?
Okay. So do y'all see what she has written up there? Like the 25v squared minus v. So if you look at this thing, the first thing that we want to do and I didn't ask it because there really wasn't one, but we want to look at if there's a GCF, right? So if we look at this 25b squared minus 1, can we take out a GCF?
No.
So there's no v's in common, right? Because there's no v's on that 1. There's nothing in common between like 1 and 25. But if we look at something like what, 25v squared minus v, and this is why we say like first step,
You have
it's
V.
always to look for that GCF, right?
Mhm.
So if we see something like this, we can take 25v squared minus v. What do they have in common?
We have V as a GCF.
A what?
We have V.
A v in common, right? There's a variable v. Let me get like a darker color. That's not a good color.
Because I am using my listening skills here. Okay.
And if I do that, I have a 25v squared. That's going to get reduced down to what, a 25v, and I have a
Yes.
minus
1.
1. So don't forget your minus 1 there.
Sorry, I have a question. I actually put the answer 5v parentheses for 5v minus 1, 5v plus 1. Would that be wrong? Like I put 5v and then a parentheses 5v minus 1 and then parentheses 5v plus 1.
So this is a thing that we had previously, right? Is that what you're asking?
Yeah,
And what'd you put instead?
I put 5v above the 5v minus 1, like on the before the parentheses first one.
Like that?
And then I put what you just put. Yeah, I think that's wrong though.
That's
going to
throwing,
have your
yeah, you're
cubes.
throwing an extra number in there is what it sounds like.
So you're just distributing the ordered pairs, or sorry, the parentheses for these. Okay. Got it.
And this is that for that 25b squared minus 1, right?
Yeah.
So see the difference? Like they both have 2 terms. That's where students get mixed up. That's why I wanted to mention it. Both of them only have 2 terms. They're both binomials. The 25v squared minus v and the 25v squared minus 1, they're both binomials, but they're solved differently, slightly.
Yeah, and the other thing that tells you like this isn't a difference of squares is like that is a perfect square, right? But if we look at v, is that a perfect square just by itself? Can we take a square root of v and it get prettier? Nah, it's gonna get uglier. We're gonna get square roots in there, right? Don't want to go that direction to factor it. Questions about this? Because those first like 4 problems are basically this thing, right? Do it, and then you want to also check your solution, right? You might be able to do it multiple times. Sometimes they like to hide other factoring techniques within this factoring technique sort of thing. So I think I want to give y'all like a little bit of time to practice those first 4. So I think we're going to go to breakout groups, and then I will bring you back, and I will show you the other thing that they introduced in this lesson. Questions about this thing? I guess the other thing was like the general form. I think they say what, a squared minus b squared. So this was the thing that they said was a squared minus b squared. And we break it up into a plus b, a minus b. So I think that was the notation the book uses, something like that. Basically what they're telling you to do is take the square root of both of these things, make sure they're perfect squares, take the square root of both of them, throw a plus, throw a minus in the middle, and that should be the factoring. So you have done distribution the other way around, right? Where you've seen that middle term cancel out. Now we're doing factoring, we're going the other direction. All right, let's go to Hertz. Open it up. Pick squares. And so what do we do if we think something might be a perfect square? What are the indicators something might be a perfect square?
You can see.
Is it the number that times itself?
Yeah, we're looking at this thing and we notice like 4 is a perfect square. And what about this number? So we look at the first and last number. If we think something might be a perfect square, is 4 a perfect square?
Yes.
Yeah, is 169 a perfect square? Can we take the square? Ooh, dropping things. Can we take the square root of it? Is there a square root of 169? Is that a big one?
No,
Yes. You said
No.
because 13 times 13 is 169.
Yeah, 13. And if we take the square root of 4p squared, what is that?
2p.
2.
2p. So the numbers I'm getting out of this are 2p and 13. So I look at the first thing, I look at the last thing. I think this is a perfect square. So either it's a 2p plus 13 twice, or it could be a 2p. Ooh, whoops. I can't just delete some of it. No, I didn't even want to bring it back now. I don't know. Ooh, what's happening? It completely said I didn't even write that now. Okay. So either it's a 2p plus 13 happening twice, or it's a 2p minus 13, right? So which one is it? 2p minus 13. Which one is it and how do we know?
the subtraction sign,
It's the subtraction sign right there. So which one of these would it be then?
the bottom one.
Have to be this one, right? And we suspect it's this one. They could have just like gave us something weird. So it might be worthwhile since we think it's 2p. I don't know why it keeps deleting everything. It's being kind of weird. But we should probably check to make sure this thing, that middle term actually matches. And I think it does. But if we do what, 4p squared, so doing some distribution, and I'm going to go what, minus 2 times 13 is 26p. And then I have 13 times 2, which is also minus 26p. So doing some distribution, and I think this last thing is plus 169. Does this thing in here equal that minus 52 that they have?
Yes.
Minus 26 and minus 26 is a minus 52. So it's a good idea to check it just to make sure that middle term still matches up.
I have a question. Do the middle number? Okay, never mind. I was gonna ask, do the middle number have to be a perfect square as well? But I just figured out the square root of 52 is not one. So
Yeah, so we're essentially checking the outside numbers when we do the square root, right? When we do the square root of 4p squared, we're getting this 2p and we're getting the 13. That's essentially checking the outside numbers. So the only other number we need to check is that middle minus 52 to make sure that thing actually equals this sum or this subtraction that's happening in the middle.
Excuse me, teacher, which is this number of exercise?
This was from the book. Let me bring it up right quick. It was 166 was the number.
Okay, because it's not in the list, right?
It's not in the notes. No, it's straight from the book. I pulled this example from the book just so we'd have an example of a perfect square.
Perfect. Thank you.
I was about to say, it looks a lot like 181.
If it
problem
was,
sheet.
what?
Yeah, the problem that you're doing now, it looks like number 181.
You know, you still have your voice mod on, right? Okay. If this was a positive 52, right? We could change it around a little bit. I think we would end up getting the plus 13, 2p. I can't write anymore. 2p plus 13. It's a small change, but it does change the overall. And they call these perfect squares because we can write it as the same thing. Being squared. It's like a square with 2 dimensions, right? 2p plus 3 by 2p plus 3. it's perfectly squared. When we do a box, it's going to be the same dimensions. That's where that sort of name is coming from. Questions about this thing? So basically you're checking the first and last. The first thing you should do is check for a GCF. I did skip past that part. So maybe look at the GCF, but there is no GCF here. We have even and odd numbers. So that, I think that right away is like ruling out quite a few numbers. We can't divide by 2. We can't divide 169 by 2. We can't divide it by 4. So it doesn't look like there's anything in common between what 4 and 169. 4 is nothing but 2s. 169 is nothing but 13s. When we break it down. So looking for those common factors first is something that we really should do, and I like skip past. And I skip past it largely because there are none, right? But it is something we should look for. Sometimes we have perfect squares hiding in there, and we just have to factor out the GCF first. That does happen. So what were the problems now? Let me bring up these problems. We got 25 v squared minus 1. I think we did that one already. Clear my drawings. They're all drawings, apparently. No, you don't want to do that. Now you do.
25.
Stop sharing this. I'm going to reshare it. I'm going to reshare it and see if it's a little less glitchy. 177 is 4 minus 49x squared. And so this section is about difference of squares. So hopefully we're asking ourselves, is this a difference of square? Where's Carson?
You want me to do it?
Yes, Carson, where are you at?
Oh, okay. I'm right here. Okay, so basically I just looked for the square root of 49, which is 7. And then square root of 4 is 2. So it would be negative 7x plus 2, and then 7x plus 2, I think.
It sounds like you swap things around right quick, right?
Uh-oh.
So the negative's in the middle there. So I think we want to write them in that order. So I think you said minus 7x or something. Did you say that?
Yes, I think I did.
Yes, she says.
Yeah, I forgot what exactly you said, but I think we want to do it sort of like this. We want to keep them in the same order. So they are a little bit reversed from like what they were last time, right?
Mm-hmm.
The other thing is there a GCF between what, 4 and 49?
No.
No.
This is nothing but 2s. That's nothing but 7s when we break it up. So I think you might have said minus 7x plus 2. Is that what you said? And 7x plus 2. So yeah, you can do that. That's the same thing.
Oh, okay.
Is that standard form at the bottom or just another way you could write it?
I feel like I would probably accept either way, if I'm being honest. Neither one really looks any cleaner to me. Because we're about to get to the next step where we solve these things, and both of those things are going to be about equally as hard to solve. Do you have a preference, Ms. Wise?
No, I did the 2
Negative
minus
comes out?
7x.
I mean, traditionally, the negative comes out, if that's what you're asking.
Out of these things that we should go in descending order? Is that what you're saying?
I mean, traditionally, I don't know, are you fine with them doing negative 7x plus 2 turned in? I mean, traditionally, you would factor out the negative. You don't leave a negative in front of an x or an x squared. But That's just traditionally how it's done.
I was
You mean
really-
teacher we needs to put the negative out? Like as
Traditionally, I mean, that's how I've traditionally seen it in books and I've seen professors do it. But if I don't know, do you mind if they leave it like this?
to me, any of these forms is equally as good, because when we get to solving it, like
It doesn't make a difference once we
any
solve
of these
it.
steps, yeah, it really doesn't matter when we solve it. I guess what you're saying is we should probably technically lead with the leading term. for all-
I mean, technically in the factored form, the -7 should come out, the negative should come out. And the reason I like to mention just what's happening traditionally is because if y'all ever do take another math class, I want you to just be aware that that's how it's mostly done, so that when you see it in that class, you have heard it. It's not like oh, I didn't know that.
Okay, so if we put this thing in descending order, now we're looking for a GCF, and the rules with GCF is if it leads with a negative, we should take out a negative. And so if we follow that rule, we're taking out a negative. And this doesn't look like a difference of squares right off the bat if we like rewrite it. But if we factor out a -1, it might start looking a little bit more, hopefully, like a difference of squares.
in this case, it's going to be changed, our function. If we put the minus out as GCF,
So
right?
you'll still get what, 7x?
Yes, 7x minus 2 times minus 7x minus 2. But
It should be 1, right?
personally,
That's 1. It should be 7x plus 1 and 7x minus 1.
no, because one of them needs to have minus. Because we have 4 minus 49 y squared.
There, +4.
So yeah, I'm
The
not seeing.
original function, teacher, excuse me, our original function, it's 4 minus 49 y squared, right?
It should be 1.
It's not
Why
4.
why does it turn into a 1?
It should be. Ooh, it is 4 minus 49. That is correct. I wrote it incorrectly.
Then I find my solution. That's 2 minus 7x times 2 plus 7x.
Yeah, so it should be 7x plus 2, 7x minus 2. And we bring down the -1 that we factored out. So just putting this thing in descending order, if it leads with the negative, we pull out the negative. And then we have a difference of squares like 49x squared minus 4. It's basically the same thing we did, just kind of flipped.
Yeah.
I have a
Questions
question.
about this?
Yes, so I'm just trying to understand, when we have problems like this, we need to always make sure to put them in descending order.
By convention, yeah, that's what they're doing.
Okay.
If it's a difference of squares, like I said, I'm not really that picky with it.
Cause I have the same answer you have. I just don't have the -1. So, but at first I'm like, how did you get that? But I noticed when you put it in descending order, that's how you end up getting it. So I'm just trying to clarify that part.
Yeah, it had to do with the fact basically that this thing was leading right there with that negative.
Okay, gotcha.
If you don't have the negative, it should be the other way around, right? 2x plus 7. 7 plus 2x, sorry. They're
Because if
basically
we-
flipped.
Personally, teacher, I wrote it as like 4 minus 49 y squared as 2 minus 7x times 2 plus 7x.
Yeah, so if you don't have the negative, they're going to end up being flipped, basically, these things.
Yes.
If you
okay.
think about doing, like throwing numbers in here, 7x minus 2 versus 2x versus 2 minus 7x, like that's doing like 5 minus 3 versus 3 minus 5. You're still going to get the same number if you flip them,
Yeah,
but it's going to be negative one way and it's going to be positive the other, right?
right.
So if you think about like throwing numbers in there instead of having variables and stuff, sometimes that might help you like think about their properties.
the same way it works, or you wanna ask like to do it the way what you're doing it right now? To make minus out as
To me,
the same and
To me, if you're doing difference of squares, it's not a big deal to do it either way.
okay, thank you.
And when you get to solving, it's going to be equally as hard to solve it either way you factor it. It's not making it easier either way. The other thing, who's next? Next one is what, 24p squared plus 54? Clear all my drawings. I don't know why you like to keep some of them behind. But that's okay. 24p squared
Yeah.
plus 54.
You wanna me to do
Is this a difference of squares? Ganya, you're next on the list. What do you
Okay.
need? Is this a difference of squares? Why not?
So,
Yeah, go ahead. Why?
oh, to solve it?
No, why is it not a difference of squares? Is that what you're asking?
It has a greatest common factor.
It does have a GCF, right?
Yes,
So what is my GCF here?
it's 6.
6. And if I take out 6, what does that leave me with? I believe that's what?
4p squared plus 9.
This is a square. This is a square. Is that a difference of squares?
So would that mean it can be simplified?
Can it?
Yeah, I mean, yeah.
Is it a difference of squares? What does difference mean?
I think it can. 6, 9, 4. No.
No, I said.
Oh, it's subtraction, so you can't simplify it.
Yeah.
Can we simplify that to 2p plus
Yeah,
3,
you can.
2p minus 3? Does that work?
no,
It doesn't work because why?
because of class 9.
Addition
Because
sign.
it's plus, right?
Plus,
If this is not a subtraction sign, that little trick does not work. That middle term is not going to
Okay.
cancel out, and this end up being a plus in the middle, right? Anytime that middle
That's
term
what I
cancels out, this has to be minus. If we go back the other way and do some distribution, try it out. If you want to do 2p plus 3, 2p minus 3, right? I guess that's the closest thing you could probably do. You're going to end up getting subtraction. You can get 4p squared minus 9. You could probably try to do, I don't know, both of them minus, right? Do them both minus. You could try to do them maybe both plus. You're going to end up getting a third term in there when you do those. Those are the perfect squares. Those aren't going to work to get a plus. So when we see something like this,
It's simplified.
yeah, ooh, this thing right here, right? This thing is prime, right? We did factor out a GCF. This is doable. You can factor out a GCF. But that thing right there, just this thing right here that I underlined, this thing right here is prime. I can't factor it down any further.
In this case, we can't say it's a prime or something like that. We need just to put 6 as a GCF, then times 4p.
Yeah, so
4p squared plus
so they're expecting you to factor out that GCF. If you put prime on this problem, you won't get it wrong. So let me maybe erase that just so you don't go misleading.
because we don't need to put prime or something like that.
Yeah, I was saying just that thing on the inside was
Oh,
that
thank
4p
you.
squared plus 9. We can't factor that any further is probably what I should say instead of writing that word. If I write that word, y'all are going to be tempted to write that word. Don't write that word. Just know you can't factor a sum of squares any further, right? We're going to call them prime for now. We don't have the technology, the ability to factor them any further at this moment. We got to start really using our imagination if we want to do that. Okay. Questions about this one? So always look for that GCF. I think is what they're trying to get at here. And if it's a sum of squares, there's not a darn thing we can do. And then the last one that we're working on look like what, 16z squared,
-1.
z to the fourth minus 1.
Yep.
Ooh, so I like this one. It's in descending order already. Next, Jade.
Okay, for this one, I was kind of confused because the Z has a 4 instead of just like a normal square,
Okay.
but I still did it like normal-ish. I took out 4z squared out of 16z to the fourth. That way it was still like in half, I guess. For like
This goes back to that thing, like if we square z squared, what do we get?
Z4.
That's it. So that is the square root. That's right.
Okay.
We're basically halving this thing, right? When we take the square root, we're gonna half that index, the exponent up there. So we get a 4z squared, and one of them is
-1 and the other is +1.
yep, -1, and the other one is 4z squared +1. If you did this, this is really great. Now,
But it's a perfect square, right? No.
so we got to look at this thing too. So this is good. This is a good step. We did this step great. But we still got to look at our solution. Is our solution fully factored as far as we can factor it?
No.
Oh,
This thing is factorable. What about this other thing? 4z squared +1. Do we have to worry about him?
You would factor the 4z squared, right? To make it 2z to the first.
2z. Wait, anybody?
-1.
-1 and
2z
2z
+1.
+1. Anything else I need to write here?
The 4z square +1.
Yeah, don't forget to bring your buddy down right here, right? It's your new best friend. Don't forget about her. All right.
We
Now
only
look
do
at
that, and
this.
we only do that. Do we only do that when it's like the -1, like there? Like,
Oh yeah, so we
and
did
it's
it.
not
because
it's
both
not
of these-
matching.
That's a square and that's a square, right? And if this is a difference, it's a subtraction in the middle. So that is a difference of squares. It's a difference of squares hidden in a difference of squares.
Okay.
Now we're looking at this. 2z -1, 2z +1, 4z squared +1. Are those fully factored?
Yes.
Yes. So it's important to know when to stop and when to keep going. I know they're fully factored because these are to the first power. There's no way I can break that down any further. That is not to the first power, but it is a sum of squares. It's something we can't factor any further. Ooh. That was a big bite to take, I feel like. Are y'all filled up with math now? After that. We got a few more problems to do. They are going in a little bit different direction. So those 4 were with the difference of squares is what we're basically looking at there. The next, how many are there? 7. It looks like it's a little bit of mixed practice. It looks like maybe there's some that might be difference of squares, but it looks like there's a few that might be perfect squares. There is also this sort of thing. Let me share this one instead right quick. Yeah, it's fine. I want to do this one, I think. So there's this worksheet that is like extra. If you want some extra practice, this is where we're going to go. There's a few extra problems in here, but I want to talk about this. It says, first step, before starting, make sure the terms are written in order of what powers? This is the thing I totally didn't do on that one problem.
Descending.
Yeah, make sure they are in descending power. And what's the first thing we should do when we factor it? We get it in the right order. And then when we actually start the factoring process, what's the first factoring sort of thing we should do?
Look for the greatest common factor.
GCF, right? That's what they're looking at here. And so I did the perfect square thing, but really the perfect square thing, you could do that with the AC method. And I think I said that in the notes. Like the AC method will get you there all the time. That was just like a special case, perfect square thing. So before we do anything else, we're going to get them in descending order, look for the GCF. And then we're going to look at how many terms this thing has. And so whether it has 2 terms, 3 terms, or four terms, we want to talk about the process that we're going to take to factor these things. So if it's got 2 terms, what do we look for? What's the process for factoring 2 terms?
GCF.
To see if they have the GCF.
We already did that, like up here. So we've got them in descending order. We make sure we factor out any GCF that's there. And it has 2 terms. We want to factor out 2 terms.
That's grouping.
Just 2 terms. What was the thing we were just doing with 2 terms?
To see if it's a perfect square.
Not perfect square, a man, y'all are killing me.
Prime.
Square root.
Prime.
Mm-mm.
What
What
was
is
the
the thing
question?
with what is the thing with 2 terms that we can factor?
X method.
We cannot factor. What do you mean?
We can factor difference of squares, right? That's what we're looking for when we have 2 terms.
For the power. If we have the roots for the power, for the
So
descending power.
we're looking for 2 different things, right? Like a 16x squared
16
minus like, I don't
minus
know,
1.
4. We had a few examples, right? Something like
Yeah.
that.
First one, 25x squared minus 1.
Yep, 25x squared minus 1. We're looking for that difference of squares. If it's anything that's not a difference of squares and it's got 2 terms, if it's got a sum in the middle, guess what?
We can't factor it.
Can't factor it, you're done factoring that.
Because I don't understand your question. No,
It's fine. It's like, maybe I'm not asking this clearly. I don't know.
because yes, I knew, but when we have the minus, it's going like to factor like grouping. But
So we're trying to think about how to factor these things. So the only way we're factoring 2 terms is if it's a difference of squares. If it's anything else, it's
No.
not getting factored. What about 3 terms? What's the process to factor 3 terms?
3 terms is the AC method. Is
AC method.
AC method and then grouping that.
You find the magic number, right?
Magic number.
Break it apart. And then we end up with 4 terms is where we're going to end up with. We do the AC method to get it to 4 terms. And then the question is, well, how do we factor 4 terms?
It's the same thing. You can do the AC method.
Factor by grouping, or the other way is with the box method, right? You can draw your box. Either way, factor by grouping, box method, they are the same thing. They're doing the same thing. Okay. And then there's like maybe if it's 3 terms and it's a perfect square, that follows a certain pattern. But we could really do those with the AC method. They just look really ugly. We're gonna get really big numbers. The perfect square just saves you a little bit headache with bigger numbers, basically. And if you recognize that it's in a certain pattern. Okay. So I think that's a pretty good like sort of setup of like what we've been going through, what we've been learning. And now we got to sort of take these 3 sort of things and think about like, what are we doing in this problem, right? We're going to take this and we're going to do mixed practice with this. So you got to figure out, is it 2 terms? Is it 3 terms? Is it 4 terms? Don't forget to take out your GCF first. So always look for that GCF first. Make sure it's in descending order. And then figure out how many terms you have. If it's 2 terms, is it a difference of squares? If it's 3 terms, can I do the AC method on it? Is it easier maybe to do perfect squares? If it's 4 terms, do it factor by grouping, group it. If it comes out the same, then you can do factor by grouping. If not, then you can't do factor by grouping. I think most of them, they give you with 4 terms on this, you can do factor by grouping. So I want to work on the next 7 there. Let's start with, I guess, the next 4, 233 through 239, 241, 249. Is that the next 4, I think? Where's my chat box? Where's it coming? There it is.
Quick question before we go into groups.
Yeah.
First of all, is my voice normal this time?
It sounds more normal, yeah.
Okay, well, that's good at least. And then the factoring strategy, the thing that we just messed with the 2, 3, and 4 term, is that part of the homework or is that just extra stuff?
That's extra, but I felt like that setup like was a pretty good summation of like what we've been doing in class and like what sort of strategy you should take. I felt like spelling it out probably definitely benefited everyone.
Gotcha. And there is problems with it. Do we do this and turn it in with the homework?
No,
Or
no, it's
again,
just
is it
extra.
extra?
Like
Okay.
it's not for a grade or anything. It's if you want
Gotcha.
extra practice, it's there for you. If you want me to work through it or something in office hours, I'll be there to do that. But yeah, it's not for a grade or nothing.
All right.
Because we have these notes as in the lecture notes for this.
Yeah, it's a little extra thing that's, I think it's called lecture notes. Is that what she labeled it or something? Yeah, it's one of my previous co-professors put it up in there. And I copied the class and so it copied it over. But yeah, it's just called lesson notes for 6.3 and 6.4. So it's a little extra worksheet. It's not for a grade. But if you want some extra practice, there it is. All right, so I want to go back to groups. I want to work on those 4 problems. Are there any questions over these 4 problems? I think we got, if you took those notes, you should know, hopefully, somewhat on how I'll set those up. All right, let's go. And you'll get through these next 4 of them.
Yeah, I did this one.
Okay. So I guess the first thing is, are there any GCFs here? I guess it should be the first thing.
No.
No GCFs. You see 3 terms. What do you think about?
I did the AC method.
Ooh, you did the AC method? That sounds good. So what are my numbers?
I did 2 times 7 is negative 14. And then it has to add up to positive 13. So I did negative 1 and positive 14.
Okay.
And then I wrote it out like 2n minus 1 and then n plus 7.
How did you break this thing apart? Did you break this thing apart?
No, I didn't. I kind of just like, I did it in my head.
Oh, doing it in your head. That's dangerous.
I know, I was kind of confused on like the middle part.
Okay. Did I? Yeah, it's recording. Okay, never mind. So do we want to break this thing apart? on a single line, or do we want to do the box method? I guess that's the question.
Single line.
All right, so we break this thing apart. This is 2n squared. The magic numbers were what? -1 and 14 were the magic numbers?
Yes.
Yeah.
Plus 14 and
So-
minus 8.
So how do I break this 13n apart?
-1n plus 14n.
-1n plus 14n. I break this thing apart into my magic numbers I just found. So I'm gonna have to delete this so it doesn't get in my way. But I find my magic numbers with the little x thing that we talked about. And I figured out they're a -1 and a +14. So I'm breaking this middle term, which has an n on it. So each of these things have an n on it. So basically, you're breaking apart the number and whatever variables are there. You're gonna make sure they tack along for the ride. Is that what I'm trying to say? Yeah.
To put -7.
And yeah, don't forget bring on your -7. That's still part of the equation, not equation, expression. Now, how do I do this? I went from 3 terms to 4 terms. Seems like things got more complicated, but we're going in the right direction.
Real quick.
Grouping or box method at this point, right? If you want to shove this into a box, you can do that. What am I pulling out that first thing?
The 2n and n.
I can pull out, I think I heard it, an n,
Is the n and 2n, then
and that leaves me with a
2n squared.
2n.
2n minus 1.
2n minus
Yeah.
1.
2n minus 1, n plus 1.
Kathleen, are you getting this?
Yeah, I'm following along.
Okay. So what can I pull out of the second thing?
A 7.
Yeah.
Oh,
Yeah,
sorry,
7.
Kathy.
Sorry, yeah, it's n plus 7, sorry.
And what's that leave me with?
N plus 7.
N plus 7.
What?
2n.
No, he's doing the third step, guys. It's 2n minus 1. The same.
Yeah, I think you
Oh,
might
and
be
then
jumping
you-
ahead from what I was asking. Yeah, that's it.
Okay.
Now it's all. No.
So now how to do this thing? I don't have any more room on my little white pad, my whiteboard. Well, that's the thing I pull out. I'll try to cram it like up in here. What are my 2 factors?
n plus 7,
N plus 7 and
n minus 1.
2n minus 1.
I'm not supposed to drop the n down with it.
What?
Uh,
What?
From the third step, do you drop the n down to the fourth step, or just this
So
stuff?
we're factoring out a 2n minus 1. That's where that thing's coming from.
Mm-hmm.
And if we factor that out, what are we left with?
No n on the outside.
We have an n and a plus 7, right?
Yeah.
Yeah.
And that gives me that n plus 7. So that's it. If you threw another n there, how many n's are in this thing? You can also count the powers on your n, right? We have an n to the single power, n to the single power.
One.
That gives me 2 powers of n. We started with 2 powers of n. So if you threw another n there, you would end up getting a cube, right? Instead of a square. When you go back, multiply things through. So counting the powers of your n's might also help you not throw in extra symbols that don't need to be there. Questions about this one? And so this was 3 terms. We talked about 3 terms as the AC method. All right, what was the next one? The next one says something like 8m squared minus 32. And who's on my list? I think Ashley's the next name on here.
Oh, Lila on me?
Yeah. So what about this one? What do we notice? 8m squared minus 32.
Okay, I'm probably doing it wrong, but I end up taking because I end up writing that number wrong instead of 36. I mean, instead of 32, I put 36. Yeah, I said, let me fix it.
It's not a difference in squares as it is, right? Like I think 32 is not a perfect square.
But
So what do we look at? Like, what's the first thing?
to see if there's a greater common factor, right?
So what is there a greatest common factor in this one?
Yes.
What is it?
I just remember it. Right, 32, it would be 4.
We divide 32 by 4. We get what?
Number
16. Is that what I'm doing in my head? I think so. And two numbers. 8. Sorry.
I'm sorry, I'm stuck.
Okay, so we're looking at a greatest common factor. And you said 4, but I think that's going to leave me with what, 2m squared minus 8. And so I think we can factor out more than that.
I see what you're saying. So
Because 2 and 8 still have stuff in common.
We can factor the 8.
Yeah. So if we're looking at the 8, right? Does 8 divide 32?
Yes, it's 4, minus 4.
Yeah, so we can divide 32 into 8.
And then you'd have 2 and 4.
M squared.
And
So we
square
divide
minus
m squared. It becomes
Minus
m
4.
squared. We divide this, it should become minus 4.
and then it just that be your answer, right?
We got a GCF out. Now we're looking at this thing. Can we factor it any further?
Yes. You'll take m. You'll take m on one side, well, on both sides, and then you could do 2, and then one of them need to be a positive, and the other one need to be a negative. So your answer would be 8 parentheses m plus 2 parentheses m minus 2. Right.
Yep, exactly it. Yep. So we're busy. I think one thing that people do is they see this m squared minus 4. They're like, I can factor that m plus 2, m minus 2. A lot of times they'll forget to bring down that greatest common factor. You'll end up leaving like this thing off, right? So don't forget to bring down the 8. Don't forget to bring that thing down. But yeah, that's absolutely it. I feel like it's a magic trick. We get you distracted with that m squared minus 4, and you completely forget about that other 8 in your left hand, right? It's like, okay. And the next one, 241. And I don't know how to reemphasize this, but like you're not gonna learn this stuff without like picking up your pencil and putting something down and trying something. Getting stuff wrong is how you learn, right? And hopefully you get a lot of stuff wrong before you get to the test and you get stuff correct by the time you get there. The more stuff you get wrong, the less times you typically keep getting it wrong, right? It's like you stumble over that hole, I'm not gonna stumble over it again, probably. Only a few more times, but I'll eventually learn. 25w squared minus 60w plus 36. Who is next on my list? Vanessa? Did you get this one? Fernanda, did you get this one?
Can I help with that one? 'Cause I feel like I want to redeem myself.
All right. If you want to jump in, yeah, go ahead.
Okay, so what I end up doing was A times C, right?
You can do that in this one, yeah. So that's going to give you some really big numbers.
Yeah.
25 times 36, 900.
Mhm. But I end up doing 30, 30 times 30. Right?
Yeah, this will work.
And then the 30s need to be negative because B is 60, negative 60, right?
Yep, you're basically doing this thing with the 900 up here, and we want a minus 60 in here. So the two magic numbers that multiply to positive 900 and add to minus 60 are minus 30.
Right. So then I had to rewrite my problem, and I had got 25W squared minus 30W minus 30W plus 36.
So we want to break this thing up. Ooh, let me do my pen. We want to break that thing up into those magic numbers we just found, which were minus 30 and minus 30. So this is my side work to find minus 30 and minus 30. You might have done this one a different way. And if you did, we might talk about it in just a second. So we're breaking that middle thing up into minus 30W minus 30W, what, plus 36?
Yes. And out of 25W squared and 30 and negative 30 square W, I end up taking out 5.
So we're factor by grouping now. We do the AC method. It breaks up that middle term into the two magic numbers. We look at these things, try to find a GCF factor by grouping. And what'd you say? You pulled out a 5W?
Mm-hmm.
And was that?
W minus 6, right?
Say 5W minus 6?
No, what's in parentheses? It had left me with a W minus 6. Because me and my brother were trying to talk about it. So this is what we end up doing.
So if you pull out a 5 from 25, it should still have 5 remaining there, right?
Yeah.
How? Because I thought if I end up taking 5 for 25, I could take 6 from negative 30. Right?
I think what you're saying is correct, but if you're dividing this by 5, right? You're going to be left with 5 on the inside still.
Oh. Because what I was thinking was, since I trying to take divided 25 by 5, that 5, that's where I got that 5 on the outside from.
Yeah, you divided it by 5 and you're left with 5.
Okay.
5 times 5 gives me back to 25.
Right, but why you got that on the inside? That's why I'm lost there.
Because we're doing 5 times 5, right?
Yep.
Okay.
And that gives me back to this 25 that's up here. We're dividing 25 by 5 is what we're doing essentially.
Okay.
And you told me take out what, 6 out of this thing? I think you said that.
Yes.
And what kind of 6 should I take out?
A negative.
It should be a negative because this thing leads with a negative. It leads with the negative, you take out the negative. And if I take out a negative 6, what's left in my parentheses then?
A W and a 5.
A what?
I did something wrong. A W and a 5?
Yeah. What kind of, what should be on that W? If we do 30 divided by 6, it's going to leave me with what?
A positive 30. Negative 30 divided by negative 6 is going to leave you with a negative.
30 divided by 6 is what?
5.
Yeah. So this should be 5W. I guess a negative 6. And then if we divide this by minus 6.
That'd be -6?
Yeah, it's it.
No. Okay.
And maybe, I think maybe you just didn't want it to be this because it does the same thing. So you're trying to make it different, or maybe, or something. But no, I mean, it's correct that it's the same. We're gonna pull out. What's the thing we can pull out, and what are we gonna be left with?
You could pull out 5W minus 6.
And I'm gonna be left with
5W minus 6.
yes. And so you can
So-
absolutely do this the AC method. And
I had the same answer. I don't really know how I got it though, but I put 5W minus 6 squared, like on parentheses, since it's the same thing.
Because we have the rules for
Yeah.
A
If you don't-
minus.
if you want to
I
do
might-
this,
Yeah.
yeah,
Okay,
if
go
you
ahead.
want to do this as some other way, right?
Yeah,
It's not
what I
this way.
did.
If we look at this equation starting off,
It's like A minus B square. It comes automatically.
we can look at the first and last, right? And if we notice that these things are perfect squares, we can use that perfect square formula.
Yeah.
Or try to, right? See if it works. So if I was thinking this is a perfect square, the first thing I do is what? Square root of 25 is
5
5, and W is the square, yeah, and then we have what, 6, 5W and 6.
And we need it to be positive, so we make the 6's negative.
Well, this thing is what we're looking at now.
Oh, okay.
We're looking at the sign right there in the middle term, and that's going to determine the sign on the factors.
If it's the same, is it the same answer if I put 5W minus 6 and then a squared and then parentheses?
No.
Because it's twice.
Like this with the square up top.
Yeah.
That's exactly the same thing.
What you said, you mean exactly if we have 5y minus 6 with 5y plus 6?
That would be a difference of squares. That is not a perfect square. We can't abbreviate it with the exponents then, because the signs are different. They're not exactly the same. These are exactly the same. Every sign, every symbol in there, we can abbreviate it with that square sign up there. All right. The next one. Are there any questions about this one? So there are multiple ways you can do these, like I said. If you notice the perfect square pattern, it might save you a little bit of time even. If not, we worked at doing the AC. Ooh, excuse me. We worked at doing the AC method. That's a perfectly valid way to work these things. It may not just be the friendliest, right? Fidel, I think is the next person on my list. K to the 4th minus 16. I think we had something pretty similar to this earlier. It might have been slightly different.
Wait, did you call me?
Yeah. Did you get this
Okay.
one?
Yeah, I did. So what I did first was K squared minus 4. And then another K squared minus 4. And then you could still distribute that, so it'd be K minus 2.
You said K squared minus 4 and K squared what? With the second factor?
Plus 4. The other one would be plus 4, right?
Yeah, the second one should be plus 4.
And then I did K minus 2, then K plus 2. Then you just bring down the K to plus 4.
Yep. So I think we did something pretty similar to this earlier, but this is that one of those where it's like nested within itself, difference of squares nested within difference of squares. So we're looking at K to the 4th. We try to take a square root of K to the 4th. That is what? K squared. We're looking at the 16. We try to take the square root. That is 4. And so it is that plus and that minus to get this difference of squares. Then we're looking at this line, and we notice that this thing can still be factored further. So we can take a square root of k squared. That gets me down to a single k. And 2. And it's a plus minus, opposite signs. Minus plus, I guess is what I did here. And just bringing this thing down, right? Can I factor that any further?
Yes, if you want.
So those two things I can't factor any further. They're both first power. And then I look at this thing. This is a sum of squares. I can't factor that thing any further, right? So knowing where to stop is also part of the battle here, I think, right?
We gotta let them go.
Is 140? Oh, it's yeah, it's already after. Okay. So that's it. That's all we have time for today.